want us to attend to. Okay, so at GDG OAU, what we do is basically anything tech. We are a developer community, so we have those in software engineering, in data, in cloud computing, website development, front end, back end, and this is the data science and machine learning section of that. So for today, we are having a discussion, or yeah, I think that's what I like to call it, a heart to heart talk on what a day in the life of an ML engineer. So if you are here on this call, I believe you want to know insights into what a day in the life of an ML engineer is. So I'll be reading the bio of our amazing speaker on the call. And yeah, it's going to have the floor. So not to keep our time, we're going to get started. So Christopher Ibiam, I'm not sure if I got the spelling of this surname right, but yeah, he's an ML engineer leading the ML strategy at Quora, an African payment processing platform present in multiple countries and markets within the continent and beyond. Currently, he oversees a portfolio of mission-critical ML projects, including churn prediction, merchant volume forecasting, fraud detection system, etc., deployed across mobile money, virtual bank account, and card payment rails. His work combines production machine learning with deep domain knowledge of African payment infrastructure, including mobile network operator constraints, mobile money floats mechanics, and regional regulatory requirements. Is passionate about practical ML engineering, and outside of work, he engaged deeply with literature, philosophy, and economic system, all of which are things that use the past to detect the present or future. Ladies and gentlemen, please join me. Welcome Christopher. Hi, Christopher.
Hi Olamide. Good,
Hi,
good evening. Happy Sunday to you. Hi
Sunny.
everyone. Good evening. Can you hear me?
Yes, we can.
All right. So should I just kick off?
Yes, please. You have the floor.
Okay. Once again, hi everyone. Good evening. Chris Ibiam, Christopher, but Chris for short. Um, I'm an ML engineer at Quora. Uh, I don't know if I should repeat everything that Olamide has said, but Olamide, thanks for the intro. Uh, so because today is Sunday and just not to bore anyone, I think I'll just get into it. So yeah, the most interesting part, the day in the life. Okay, so a day in the life of an ML engineer. Um, I wouldn't say it's like any other role that I've had the opportunity of looking into from like the outside window. Yeah, I've not really had work experience in any other roles apart from ML. So in terms of like the the world of work, ML is all I know. In terms of just the world of work, ML is all I know. So yeah, our day is not the conventional, you come to work and you have a set of tasks that you have to complete before the end of the day, and when you're done, you clock out and you go home. It's not really like that, especially with me. So with me, because it's with me and my team, rather, because it's project-based work, um, we start the day by, you know, we start the day depending on, whatever happened the previous day. So let me just let me just break it down like this. So it's project-based, it's heavily project-based. Like Olamide mentioned, we have different systems built typically in the ML world, or in a company like Quora, where it's financial products. You have the mobile money rails in Nigeria, Ghana, Kenya, and other countries. You have um card issuance, and you have virtual bank accounts. So those are three different products. There's also differences in the geography of it. So let's say you're building a fraud. model, for example, a fraud detection model, for example. Um, I mean, it's obvious you want to use data from the past to predict the future, but it's not as straightforward as it seems. And because it's not, like I said, it's not like the conventional um day in the life of another professional. It can change, in terms of the type of work you're doing, and it can also change in terms of the phase of the project that you're currently in. So, for example, fraud. It starts with in a normal ML pipeline, or let me just use data science for this use case. I prefer using data science because ML is more production focused. I know you guys want to hear about what happens in production since you could already be used to the theoretical aspect of it. But I think I should start with that theoretical aspect of it because it can't be missed. So in the theoretical aspect of it, we always start a project with research. As a data scientist going into the field, and even one still um, learning where to place their foot in this industry, one thing that would be a differential amongst your peers when get into that space is your ability to be able to dive into any domain and not gain expertise, but gain something close to expertise. For example, if you let me just move totally away from finance. For example, if you're going into the oil industry and you're building a model that predicts the that that predicts the probability of oil being in a certain geography, then you need to know a lot about oil. You shouldn't research based on what would be important to your project, but research based on, the perspectives of every other professional in that space. So yeah, a lot of research should be done. You would have to read a lot of research papers. For those who like, for those who are curious, it will be an interesting time for them. For those who are not, I'm not going to lie to you, it's going to be a boring time for you because it's a lot of research papers, a lot of articles. So the most important thing at the start of an ML project is research. You need to know what you're getting into because it's going to help you further down the line. So this kind of thing would, before AI, you know, the generic AI that we all know now, that's the LLMs, before they came into play, um, we were sort of doing it manually. So research, you just go to Google Scholar or you go on the internet and type up what you want to research on, and it brings out different things. You have to read all those papers to make sure you're not missing anything out. But with AI now, I think research has become easier. Um, but it still doesn't like flush out the need for looking at actual research papers because, of course, as we all know, AI isn't 100% accurate all of the time. So yeah, research is much easier these days. It takes less time. So let's say a day in the life during that research phase can take, I think, about 4 days. 4 days now. Before it take 2 weeks. And as somebody that's curious, you might still not even be satisfied with what you have. But this is easier. It take like 4 days and then you're out of the research area. So when you're and as I talk, if anyone has any questions, feel free to interrupt me. Just raise a hand or ask any questions at all. Okay. So when you get out of the research area, you've gotten, you know, all you want. You're sort of like you have that, yeah, the position where you have fresh knowledge about what you want to, the projects you want to build or the projects you want to work on. Um you're even more excited about it because you feel like you know more than somebody else that more than a regular non-expert So you're more excited, you're more driven to go for it. So after that research area, there comes the conversations you would have with um the stakeholders relating to data. So that's where you talk to your data engineers, you talk to your data administrators, you talk to the engineers themselves. Because sometimes it's the engineers that, in my case, or in the fintech case, it's the engineers that build the the payments infrastructure. So they know everything about the data. So you have conversations with them, you tell them what you want to do, you explain, you just give them the full breakdown, and they give you access to the database, or sometimes you already have access to the database, but it's not every um it's not every data set what it is like. You're not aware of what most columns are. So that's what those conversations are for. And then you have that conversation, you're given that access, and then you move on. Mind you, of course, all of this is not happening within one day. It's spread across the project life cycle. So, like I said, it starts with research. One morning you wake up and all you're doing from morning to night is you've essentially turned into a master's student or a PhD student. You have your head buried in between research papers and you're just looking. But then the second phase is the talking to different stakeholders, where it's not about research. And I mean, you're still carrying out research, but this one is mostly meetings with stakeholders. So you're having these meetings, you're talking things out, and then you get everything you want. This one usually lasts a day or two if the team is quick enough. And then you move on to, you've gotten your data, you've gotten a sense of what the data looks like, data that will be useful to your project. And then you move on to the data ingestion phase, right? And now I'm moving from theoretical to sort of practical and production based. So I don't want to miss this out. I don't want to miss this out because I think it's important to the production level projects. So one thing you need to get right um when you're building an end-to-end ML pipeline is the data ingestion. So, and I think one thing that everyone here would hate, especially after learning a lot about ML, is going into a company where they don't have their data rights. Because if the company doesn't have their data rights, you cannot get a reliable model, no matter how good you think you are. You can't get a reliable model. So it's important that the data is right. So once the data is right, or in a case where data is right, that means that the establishment has a good data infrastructure. And if they have a good data infrastructure, then it shouldn't be an issue. Data ingestion and data pipelining shouldn't be an issue. So the reason why I'm saying this is because you want to be able to, you know, because now this part is mostly demand your knowledge of SQL. So you need to know what to do to pull all the relevant data. Also make sure that the queries are not too resource heavy so that you don't, you know, um weaken the data integrity. Not the database integrity rather. So you want to make your queries efficient. I mean, you can have these discussions with your data engineer. They can advise you on what to do best, but if you're seasoned enough, you know what to do best. So you pull in data points from different data sets, from different tables, but from one database. That is if that data infrastructure is right. And then what happens next? That's you getting your pipelining ready. So now you can have two types of models typically in real world scenarios. A model that is either focused on online prediction, and then a model that is either focused on batch processing. So what I mean by online prediction is for something like fraud detection. The goal of fraud detection is that as transactions come in real time, you want your model to be able to detect them in real time and then block them in real time. But if you're building a model like um, churn prediction. Churn prediction is just, in our case, is just, oh, you want to build a model that predicts when your customer is likely to leave your company, or you want a model to predict if your customer, in this case, a merchant, is going to leave, is going to stop using your services in the next 30 days or the next 60 days. And the reason for that model, the aim of that model is so that teams like the sales team and the merchant success team will reach out to them and retain them so that you don't lose money. So now for the churn, because it's not needed immediately or the results are not needed immediately, that's what they call batch processing. So batch processing is just carrying a bunch of data points or a bunch of rows of data and then pushing it into the model, and then the model gives you output. But online serving is that once one transaction goes in, a result must come out almost immediately. So the decision is not taken in seconds, it's taken in microseconds. So it needs to be fast, it needs to be effective, it needs to be efficient. So that's the difference. So you need to know what output your model is going to bring out, and that would help you in your data ingestion pipeline. That's a conversation you would have with the data engineering team. Yeah. So after that is done, after that is done, you're moving on to the next phase, which is data pre-processing, which I feel is the easiest part of ML. Um, all you need to do in data pre-processing is just clean the data. So, and I think honestly, this takes less than a day. So that particular day in the life is going to, if you're a content creator, that particular day in the life is going to be extremely easy for you. And you just be happy, you just wrap it up quick. So, you just get your data. It can be in tens of millions, or just hundreds of thousands. You clean it, you remove duplicates, you drop duplicates, you analyze the data, not analyze, but sort of you just scrub the data. It's not all null values, and this is a mistake that most people make. It's not all values, it's not all null values in a data set that should be removed. They should actually be understood. And in this point now, it's not sort of like an iterative process with the engineer. So when you look at null values that you don't understand, or if you look at them and you've seen that, okay, this thing is not just a data error, I don't know exactly what this thing is, I need someone to make it clear to me. So you hop on with the engineers again, understand why that null value is, what it is. And sometimes you end up not dropping that null value, but you can turn it into something else. And I know there are other methods of, a null value might not be important, might not be useless. So, you have to compute the averages of the data set and then assign it. I mean, it can be a bit misleading, a bit misleading for some models. It can be a bit misleading for some companies because these data sets are specific to companies. Some of them are specific to industries, but some are specific to companies. So you don't want to use generic rules that the data science industry or the data science community would give you. You wouldn't want to exactly apply it, right? You wouldn't want to apply it directly without understanding your data. Understanding your data is easily the most important thing in an ML lifecycle. So yeah, when you do that, you remove null values, you remove duplicates, understand null values that shouldn't be removed, and you know what to do with them. Like I said, that takes less than a day. And then you move on to the next, which I feel is the most important. This is a very subjective, this is just my opinion, but I feel it's the most important part of um, the pipeline, the exploratory data analysis, which is the EDA. So what happens in the EDA? This can take, those days it used to take, it could take 2 weeks, like research. But now you have AI, right? And it's not going to take as much time. So your goal for this phase is just to actually understand your data, draw a lot of plots, draw a lot of graphs. There are times where you'd see some stuff and you'd uncover some insights and you want to run them by the business, to make progress. For example, let me just look for an arbitrary example. If let's say you're looking at a fraud data set and you're trying to see which demography of users perform fraud the most, and you find out that, or you want to see which industry fraud is coming from the most, and you find out that it's the companies, because for payment processing companies, our customers are not end users, our customers are merchants, our customers are businesses. So you find out that for payment for companies that are, let's say for crypto companies, for example, those guys, now this is just I'm just using this as an example. Obviously, I'm not going to disclose whether it's real or not. So you find out that in the crypto industry, that's where most of the fraud is happening. And then logically, you're meant to say, okay, any industry that shows, copious amounts of fraud should be immediately flagged. That's the logical thing to do, right? But then you have a conversation with the business, and then you find out that that is actually where most of our money is coming from, the crypto industry. So if you are going to flag the crypto industry in while training your model, then you're going to say, okay, assign a certain score to transactions that are coming from the crypto industry. And because of that, your model is going to be inclined to lean towards crypto type transactions as fraudulent. And because of that, you might get a lot of false positives, which would make you lose a lot of money and a lot of merchants. So you don't want to exactly follow your own insights. You want to be able to the research. Why I think research is incredibly important is that it doesn't just happen at the beginning of the project's life cycle. It is spread across every single part of the ML life cycle, from data ingestion to pre-processing to EDA to feature engineering to feature selection to model training to model selection to deployment. You need research. So in this EDA point now, you need research. So when you uncover some interesting insights, you always have to run it through the data analyst, or run it through the business analyst, or run it through the business itself, like key stakeholders. If the company is small enough, you run it through the management, right? So it's always very, very important to, be context aware. So you have to make sure that you're not making any decision purely logically, which is why a data scientist in a company or an ML engineer is a key stakeholder. So that happens in the EDA phase. You get to look at the data, you see some interesting things, you see some interesting numbers, you pull out incredible insights, and that now takes you to the next phase, which is your feature engineering. So feature engineering is important because of what comes out of EDA. So for EDA, you identify the parts of the business or the parts of the data that will be interesting. And for feature engineering, the goal of feature engineering is just to expand your feature sets, right? And the reason why you're doing that is so that you don't end up using only the data that you ingested in the beginning, because quite frankly, you're not going to produce a good model if you only do that. You need to be able to engineer features from the features that already exist. So the feature engineering phase doesn't take, it takes a fair amount of time, maybe like 1 week. It's also a very, very iterative process. So feature engineering is heavily linked to model training. Um, so if you're feature engineering, you have to expand the features as much as possible. Um, you also have to uh, compare the features against each other, which is where you have your heat maps. Um, Map the features against target variable. See how well it's what was that word? See how well it's sort of uh sorry, yeah, exactly. Thank you. See how well it correlates. So you use your correlation matrix. Use all those use all those things that would bring out your data. And even if there are some features that even if the data is telling you that it doesn't correlate, I can assure you it will be important, which is why you should be able to know your industry, know the data, know the projects, or rather know your domain, know the data, know the industry, know the projects, because it's those things, it's a combination of those things that would help you to bring out the best model. So after that, you get your features. At this point, let's say you started with uh about, let's just say, 23 features. At the end of this phase, it's very possible that your features could expand to 78 features. But it's also important that you know that it's not the size of your feature set that would determine how good your model will be. Some of that may just be noise, and you need to know which features are noise. So after feature engineering, there's feature selection. I like to look at them as one because I don't like to have too many phases in anything I do in life. It just makes stuff more complicated. So for feature selection, it's where it's the most it's literally the most one of the most frustrating. Okay, so feature engineering, feature selection, and model training. I like to put them in a ring. I call it the most frustrating part of ML. Personally, it's not the most important part for me. The most important part is EDA. But those three are the most frustrating because that's where, I don't even consider it as machine learning engineering. I just consider it as pure data scientist work. And people throw, the word data scientist loosely. They forget that science is inside that role, which means experimentation upon experimentation upon experimentation. So if you're learning, I think it's important for someone that's learning, if you're learning or if you're a beginner, I feel like that experimentation phase is important to you. Of course, in production, there are easier ways to experiment, but for a beginner, that experimentation phase is very important to you. You have to do it manually. Um, when I mean manually, I just mean, oh, you shouldn't use like production infrastructure like Vertex AI. In fact, as a beginner, if you're not working somewhere, you probably don't have access to that kind of resource. So, um, yeah. So feature selection. So for feature selection, you select which features would be most important to your model. There are different techniques for that. There are also different algorithms that you need to know about. Like you need to turn into a mathematician for. It's not as if you're going to be doing math in the projects. It's just that you need to understand the math that's going on behind it because it will help you select the best technique that would help you select your best feature set. So you get that right, and then you select the features. Now that feature space go from 40, might go from that 78 that I expanded to to around 51 or 47 or so. So you push that into, you know, a model, a push that into model training phase. You do research again because it's a context type thing. There isn't one size fits all. There isn't a one size fits all algorithm. So you need to research on which algorithm would be best for my model, and then you start with that as a baseline. Um, that model training phase is just to get your baseline algorithm, just to see what things look like. So you can experiment across maybe three, four algorithms. For fraud, you can look at classifier algorithms. You can look at gradient boosters, so XGBoost, random forest. You can look at ensemble algorithms, and you just get a baseline. So when you get your baseline, for fraud, more times than not, right? Especially if you're working at the bank, because I once worked at the bank. So more times than not, you're going to have, and personally speaking, fraud was extremely annoying. Fraud model was extremely annoying because we're always dealing with um imbalanced data. And that's the thing with fraud. And that's the sort of paradox. As a data scientist, you need enough of, like, the more data you have to train on a problem, the better the model learns and better it performs in real world scenarios. So that's where the paradox lies. If you're in a company that is giving you so much fraud data, for example, let's say the ratio of fraud to non-fraud is 2 to 1, then there's a fundamental problem with the company, which means that there are a lot of fraudsters that are just operating anyhow there, which is very questionable for a company. So if you're in a decent company, how to know is that you would always have, like, um you'd always have imbalanced data. So there was a time that when I first joined Quora, the ratio of fraud to non-fraud was 1 to 47,500. So for every, so yeah, 1 to 47,500 approximately. So for every one fraud instance, there were 47,500 clean transactions. So you can imagine how frustrating it would be to be able to, find enough data that would give you good insight. So let me tell you about an interesting algorithm I used, because I used like the normal way and it wasn't working. And I wouldn't lie, right? Um, Another resource that would be really helpful for you in production, not production, but for you in a real world scenario, is the Reddit community. The Reddit community is, if you think you're good or if you think you're the best, just go to the Reddit community. You'd see people that are way better than you. And the good thing about them is that they are always willing to help. So yeah, that's it. That's once you get into that space, right, after school, that should be your, even during school stuff, that should be your go-to if you have any issues. ChatGPT is not going to help you as much as those guys would help you. So that's good. So yeah, what I used for that scenario now was that I trained the data on normal transactions as opposed to fraudulent transactions. So it sort of became an anomaly detection model as opposed to a fraud detection model. So I trained it to recognize normal transactions, and if it should see any transaction that's like it wasn't trained on, it wasn't trained to recognize, then it raises a flag. So I think that was my proudest moment as a data scientist at the time, because from something that was giving me a recall of, I think, 26%, when I used that model on live transaction data, it was giving me a recall of 97%. So, like I said, that's where research becomes very important. When it feels like there's no hope, you just go back to research. Just do everything you can because the data is somewhere or the information is somewhere in the world. You just have to pull it out. So yeah, um, let me go back because I think I've digressed. So yeah, back to the feature selection. So where you get your features, you go into model training, you experiment with baselines, and there are some times where the results would be disappointing, which is normal. So the baseline models are just to show you, oh, this is like your first try. Obviously, this is not going to be the end. And that's why I called it an iterative process. So you have to go back. You don't have to go back exactly to the drawing board. You just have to go back to your feature engineering. So from your feature engineering, you start looking for better features again, start having conversations with the business, and you iterate and iterate and iterate until you get acceptable metrics. So the type of project you're working on depends, or the evaluation metrics that you're looking at depends on the type of project you're working on. For example, recall is important to fraud and churn, but for a regression type model, you can look at other metrics like accuracy. For something like lead scoring, you can look at the metric like the area under the curve and stuff like that. So it just depends. It depends. It really depends. All that you get that from your research. And so that's it for the model building. Now, for deployments, um, which you're probably not going to do like on your own. You probably have to be in a company to be able to deploy a model. So for deployment, it depends on the data infrastructure stack your company is using. Cora uses a Vertex AI stack. So you deploy the model on GCP. So for deployment, if you're a full stack ML ops engineer, you would not need the direction of a DevOps engineer to assist you. Just get there on your own. But probably for people that are just starting out, you probably need like a DevOps assistant, and they'll just help you get on it and deploy the model to production. Of course, the life cycle of the model doesn't end there. You can't just build something and leave it to run. You'd have to go back after some time, maybe like 2 months, retrain, at least retrain once a quarter. Retrain once a quarter just to make sure the model is keeping up, because people are smart. People would be able to get around your defense mechanisms. All you need to do is just keep updating and updating in order to get the best results, because data changes over time. So that's it for ML systems in production. I left out a bit because of time, and because there are stuff that might not just concern you guys at this stage. So yeah, challenges. Before I take questions, challenges. Like I said before, it can be very frustrating to see what you've put a lot of research and what you've put a lot of work into to provide, you know, disappointing metrics. For example, the time where I worked on that fraud, I think 2, 3 years ago, it was very disappointing because I knew that the problem was the data quality, but I did not want that to be a blocker to me. I did not want that to stop me. I wanted to find another way. So I worked on that thing for months, and it was frustrating. I know how many times I had to go back to do research. I know how many times I had to go back to understand the algorithms from scratch. I know how many times I had to teach myself the math, the math aspect of it. So it can get very frustrating, especially when you don't get the metric threshold that you wanted to get at the beginning, you'd the iteration is the frustrating part. The fact that you have to go back and go back and go back. So those are the challenges. And the only way out of it is to just look at it from different perspectives and keep trying and keep trying. Eventually you get there. Eventually you get there. And it's easier now. It's easier for everyone now because, you know, there's AI. You know, 3, 4 years ago, that wasn't the case. You'd have to read articles and look for articles. Sometimes the answer can be buried deep inside a 200-page research paper, and you'd have to read the previous 100 pages before getting to that. So it was really frustrating for me. Uh, but now I think it should be easier, obviously, because it's a new experience for you guys. You might still have your own frustrations, but like anything in life, the only way out of a frustrating situation is just persevere. And it's ML is no exception. ML is no exception. So yeah, I don't know. I think that's all from me. I don't know. I think time is fast spent. If you have any questions, please feel free to ask.
Okay. So thank you very much, sir, for that workflow. So please, if you have any question, let's like raise up our hand, and if you want to put it in the chat too. So any questions that you may have, like this is like right time, and we have like the perfect person on the call. So hi, Dio, you have the floor.
Can you guys hear me?
Yes, we can.
Okay. I really want to ask you a question. Like, do you like at the beginning of this like AI machine learning, like, do you really need to learn system design? Like, as a dev, as a LM, right? Do you also have to learn system design and some Python based on data, like data analysis, also or more?
Yeah. So you and I think that's something I didn't learn at the beginning, which I had to learn later on. System design is very important to your work. Especially now that you wouldn't these days, you wouldn't exactly stop at ML. So most ML engineers these days are venturing into AI engineering. I am part of those people. So AI engineering is almost 0% of ML, a lot of software engineering. So yeah, for ML, you would need to learn systems design, but it would be very important as well if you're considering AI engineering. And yeah,
Okay.
analyst part of it. Most ML engineers or most data scientists can analyze data as well as or even better than a data analyst, which is why I don't feel like data analysis I don't think it's a I don't think it will stand the test of time. But this is just me. This is my opinion. Anyone
Okay.
who wants to be a data analyst can go ahead.
Yeah. Um, okay. Yeah, but yes.
Okay. So I think I'll Dio, is that all? Like, is that
Yeah,
all?
I also, yeah, there's also a second question, right?
Yeah, please go
Do
ahead.
okay, do you think right now that there are more of some people don't really know the difference between like machine learning and AI. Like they kind of join everything together. So as you as an expert, you kind of like differentiate what is the main. Is it you focus more on data in machine learning and in AI engineering, right? Or yeah, AI engineering, you focus more on models, right?
Okay, so there's the difference between AI and ML is that ML is a type of AI, right? It's machine learning. It can even you can even, in some ways, it can be used interchangeably, because if you define ML, you say machine learning is the act of machine learning is training a machine to, work independently of a human being, which is what Claude is, which is what ChatGPT is. You ask it questions and it doesn't need a human being to give an output. And then, yeah, you can use them interchange, but you have to be very careful about it. In conversational sense, machine learning focuses on, building predictive models, stuff that you put data in and then you get an output. But then AI is like, it's sort of like the umbrella term. So when you talk about AI, there's large language models, there's machine learning models, there's deep learning models. So yeah, I don't know if that answers your question.
Yeah, and also, like, can can you use JavaScript as your also like a backup language? Because I know Python is like the main. So can you use like JavaScript as your main as for machine learning?
Well, I've never seen that for machine learning. For machine learning, the two key languages are Python and R. I never had to learn R because I never saw a situation where I would need R, because Python is more versatile. But JavaScript, not really. JavaScript is mostly for AI engineering, because AI engineering is all about building software products and building software on top of LLM. So yeah, I don't think you need for machine learning.
Okay.
Yeah.
Okay, thank you very much for that, sir. Okay, so the next person is Israel. Then after Israel, I'll take one question from the chat, then we'll take one live question, then take one question from the chat like that. So Israel, you have the floor.
All right. Good evening, Idiam. So, for those of us like building projects, like, do you have any tips? For example, I'm kind of working on a very noisy data set, and I had to like build the pipelines, clean the data, basically everything you've said, and I'm kind of stuck right now on the feature engineering part, trying to create a suitable um, target variable for my model. I already tested it with some base model. So like, do you have any tips? For example, I have to like look for the right model. I'm still researching on that now. Do you have any tips? Like you said, you've worked on, you're a data scientist, obviously. So do you have any tips for people building, actively like building projects?
Yeah, so just to get you right, did you say that you're in the feature engineering phase and you're looking for your target variable?
Yes, basically.
So one important thing is that you have to know your target variable from the start. I think that's even
Okay, let me give you kind of a bit of background. So I am working on like a market. I'm working in market data basically. And then you need to, for example, now you have to define what a good trade is. So most trades are bad, basically. Like you said with what's it called, fraud detection. Most trades are bad. So you cannot like pick, okay, because your data will be like skewed towards one side, towards the bad side. So you have to like look for a way to make sure that your target, like your this thing represents the most of the data. So you could transform the target variables. I don't know if you get what I'm saying.
you okay.
Yeah.
So you've described there's a way to get out of that situation, because what you're describing, I'm picking it up um as something of, is it a supervised learning model?
Yeah, it's a supervised learning model.
Okay, so I'm picking it up as something like a passing balance. Is that your issue?
Yeah, something similar.
Okay, so I think a good bet would be oversampling. since because you're trying to predict whether a trade is going to be good, right?
Yes.
So in order for you to predict that, then you would need a considerable amount of good data points. And for you to do that, I think you can consider and if the good trades are on the lower end of the imbalance, then I think you should look at oversampling, an oversampling technique.
Okay.
Yeah.
Like, have you worked with something similar? Do you have like any model that you could recommend, something like that?
You could use the smooth technique.
Okay.
Smooth technique. The another one I would recommend, right? But I'm not recommending it with pure confidence because I've never put it in production. Is what I used to is what I used to when I was switching up my methodology when I had to work on that overly imbalanced data set. The one that I said that had a ratio of 1 to 47,500. So
Yeah.
um something I used something called a variational autoencoder, VAE. It's like
Okay.
a generative deep learning model that sort of generates new samples based on what you have already. But it's tricky because I've never put it in production. I just know that it worked for me at the time. I tested it on training data. Sorry, I tested it on test data. I tested it on live transactions, and it worked at the time to a degree, but I never put it in production. For me, it's experimental, but for the community, apparently it works. So you can use that. If it doesn't work for you, then you can switch up your methodology again and train on the higher balance. So in this case, you switch your goal from predicting good trades to predicting bad trades because you have a lot of instances of bad trades, right? And because of that, the model is going to learn what a bad trade is. So if a good trade comes in, it sees it as an anomaly, and then it red flags it and says, "This is not what I'm used to," right? Take note of this. So those are just ways that you can tackle that.
Okay. Thank you very much.
Yeah.
Okay, thank you very much, Israel. So I'm going to be taking one question from the chat now. And the question says, as someone transitioning from data science to machine learning engineering, what should I focus on most to make the shift successfully?
Okay. So I feel like machine learning or data science is the experimental part of machine learning. It's also something you can sort of use interchangeably. But if you're making a switch or a shift, you're not exactly making a shift because you're still going to be doing the same thing. The only thing now is that you're going to be focused on productionizing your models. So you have to learn, like Dio asked, you have to learn system design. You have to be able to know just the basics of what a DevOps engineer knows in terms of, models in production. You have to know just just a little bit of data engineering, and not too much, not too crazy. If not, you just might as well just move to data engineering. So you just need to know how things in production work and you adapt your model because as a data scientist, you might just be focused on, oh, data comes in, I clean it, I analyze it, I train it, and I send it out to whoever wants to deploy it. But now, whoever wants to deploy it has now become you. So you need to make sure that pipeline works in a manner that whenever you want to retrain, right, you don't have to do it manually because retraining takes a lot of time. So if you're putting it in a pipeline, it has to be scalable, right? It has to be able to train itself. So system design is important. DevOps is important as well.
Okay, thank you very much for that, sir. Next question that I have here is I'm an ML enthusiast and I've been learning for a while. I felt to ask what projects should I focus on in building a portfolio that stands out? Is it regression models or deep learning models?
Okay. So there are a lot of industries that need ML, and because of that, I can't just tell you one thing to do. There are a lot of industries that you go to that basic ML is useless to them, and deep ML is the only thing. There are other industries where you go to, deep ML is useless, deep learning is useless to them, and basic ML is what is in vogue. So I feel like where you are at now, you have a lot of time to do a lot of things, and I think you can achieve them faster because you're not going to be working with um production. You're not going to be working with a company's live data. You're probably going to be pulling your data sets from Kaggle. So you can, spread your wings and, see how much you can take on. Do stuff that is passionate to you. Look at the industries that you're interested in working in and just do those things. So when you find out those things, you find out if you need ML or deep learning or computer vision, and you can just lock in on that and yeah, just do as many non-generic models as possible. Yeah, I think it increase your domain knowledge. It also increase your ability as well because you're going to be learning lots of things along the line.
Okay, thank you very much, sir. So okay, I think I like this question that just came in, and the question says, "What would you say about one who uses Claude for projects? Say 70%."
70% Claude generated code.
I believe that's what the person is referring to.
Well, there is for a beginner, right? There will only be a problem if you don't understand what you're doing. There will only be a problem if, because there's sometimes that you can use AI to generate code and you can understand what it's doing, but at the same time, if something goes wrong, then you'll be lost because AI is not 100% accurate, as we all know. So the most important thing is that you understand the code. For example, if I'm interviewing ML engineers and I give them an assessment, in 2026, I expect everybody to pass that technical assessment. The place that I'll catch them is when I'm interviewing them because I'll ask them questions about their design choices. I'll ask them questions about their implementation choices. And that's when you know who truly understands what they're doing or not. So if if you know what you're doing and you use Claude to generate your code, there's no issue with that. All it's doing is that it's making your work faster and you can do more.
Okay, thank you very much, sir. Ebru Lawson, you're raising up your hand before. I want to know if you've put it down, if you still have a question. Israel, do you have another question? If not, please kindly put your hands down so we know. So
Okay.
I personally have yeah, Lawson, you can go on. You can go on.
Okay. So I just wanted to ask, like, is it how important is it for someone to have, in order to get a machine learning entry role, to have worked as a data science prior, even if let's say you already have a solid understanding of like data science concept, you have projects to show that you understand core statistics, core data science. Do you have to go through a data scientist in order to become a machine learning, or can you like go directly to a machine learning engineer, or probably maybe specialize in something like computer vision, assuming you know what you're doing?
So is your question, can you be can you be
Okay.
an engineer in an entry role?
Yes.
Yeah, you can.
Okay.
Okay, so thank you for that. So please, if you have a question, you can raise up your hand, you can type it in the chat. So I think a personal question I have is like in the aspect of technical assessment. So if you're going for a data science role, if you're going for a machine learning role, how do we handle like the technical assessment? Apart from like the foundational theory that okay, yes, we expect to know, are there any tips, tricks that you would give from like your years of experience?
Okay. So personally, what I look out for, and because it's a very big part of me as well, and I think it's something I can just share for free. So, and I think I wish I had known, this thing I'm about to say. I wish I had known it when I was in university. And it's just simple. It's just this: the easiest way to solve a problem. Some people will tell you that is to write the problem down out clearly. While that's true, and while you solve the problem halfway, for me, the easiest way to solve a problem is to break it down into its simplest components, then understand each of those components. And once you understand each of those components, you can build it back up. So now that will now lead me to say what I look out for is how they are thinking about the problem. Because an assessment would probably be like, a project. So how did they think about this project from the start? How did they break it down into the smallest components? And how have they built that project from raw data to a fully fledged model? Sometimes the for me, sure, sometimes the metrics don't mean anything to me because for all we know, that data is I probably pulled that data from a public data set. So it doesn't mean anything to me. All I need to know is what's what was going on in your head when you were thinking about building this model. How did you what did you pull from the data? What insights did you get from the data? How did you understand the data? And if you don't understand all those things and you want to work as an end-to-end ML engineer, you just you just need to go back to the drawing board and learn how to understand those things. Because if you don't understand those things, then you're going to miss it along the way. So I don't know if that answers your question.
Okay, yes, it does. So I think a follow-up question to that would be, recently we all heard about like this Monopoint CEO where he mentioned that like there are not enough senior talents in Nigeria and all that we have a human capital development. So I would say as students that we are trying to build ourselves up and when we see this kind of information, it's kind of discouraging. I don't know if like you get where I'm coming from. So I don't know, what would you say to us that we are currently building our skills in terms to relation of things?
Okay. So this question, I think someone has asked me a question like this. So what do I think about what the guy said? And for me, what he said, in terms of the content of what he said, he did not lie, right? But his delivery wasn't the best, which is why, most Nigerians did not take it well. So my main issue with the topic that he brought up was that it's very it's very foundational. So I have a personal problem with the way we are taught in schools, from primary school, secondary school to university, because all that we are thinking of is, or all that we are made to think of is, how best can I pass this exam? That's all we're thinking of. And the problem with that is, if you're thinking of that, then you wouldn't try to really understand what you're learning. Learning doesn't become fun for you. If I'm sure you would agree with me when I say I don't remember much practicality into what we were taught. It was just mostly, oh, read your books and pass your exam. And when you tell someone to read your books and pass your exam, all they are doing is cramming their books and pouring it into their exam. So how I would like to learn, or how I would like my child to learn when that time comes, is that they understand what they are learning. If a math formula is going to them, they understand why that formula is that formula. They understand what the person that created that formula was thinking about. And and it still goes back to what I was saying, the easiest way to understand the problem is to break it down into its finest components. So once you understand all those components, you're immediately an expert, right? So to answer your question, as people that are, especially, I'm sure this is your final year, you're about to just bow out from university, you're going to have to do a lot of unlearning, especially because as experts, as data science experts, you're going to have a lot of conversations with the business itself, the management. So there are some decisions that the management will take that, if you really understand what you're doing, you would know that they're not supposed to take that decision. And then not only will you be able to identify stuff like that, you should be able to communicate it in a way that they understand and they would agree. And in order for you to do that, you need to unlearn a lot of your a lot of the learning processes that you were taught. Now, I'm not saying you need to unlearn the stuff that you were taught. I'm saying you need to unlearn the type of learning that you were taught, right? So I think that once you do that, you can excel in any field. You can talk to anybody. And on Wednesday, I was talking to a bunch of CE students, and I was telling them the same thing. The beauty of being a data scientist or an ML engineer is that once you've researched a lot of projects and once you've read a lot of research papers, you can have any conversation with anybody anywhere, because you'll be able to understand that it will be easier for you to, you know, like, understand multiple domains that don't even concern you. So you'll be able to have conversations anywhere. So yeah, to get those skills that you need to understand data and algorithms and maths, it might be very, very annoying, but you need to understand statistical maths. You need to understand what the guys that created those algorithms were doing, not just the names of the algorithms or when the algorithm should be used, but much deeper than that. So, you know, I think, to put it in one line, hopefully you can remember, to put it in one line, you just need to always dig deeper. Always dig deeper, always dig deeper. I think that's what I've been doing since I first thought about it this way, and it has helped me. So I think it could help you as well.
Okay, thank you very much for that, sir. So a question in the chat here says, I'm a beginner in ML. Do I need to have the foundation of software engineering?
For ML, no, but for AI engineering, yes. Yes, for AI engineering is important. But for ML, no, you don't.
Okay, so okay, Drew Samson says, I'm a complete novice. I'm interested in learning ML. How do I go about it? Where do I start from? I need some sort of roadmap, please.
Okay, I think you can just start with the basic beginner courses that Google offers, Coursera offers. I think they have some free courses. And then when that's done, you can just go online, research projects that are beginner friendly. From beginner friendly, you move to intermediate. Just do stuff across many domains because when you're applying for jobs, right, you want to have much more options. And unfortunately, well, let me not even say this part, but when you're applying for jobs, you want to have much more, you want to have a range of options. So you want to be confident enough to say, you know what, I built something in this industry. I am confident enough to apply and I'll be considered seriously. So yeah, I think that's what I can say about it. At least that's what I followed when I was learning.
Okay, so I think what I would just say to that question is, Drew Samson, if you are a student of OAU, you should do well to join the JDD OAU Data Science and Machine Learning community, and we also have the DSN OAU. Those are the communities that you can help get started. Israel and Dio, do you guys have questions? Your hands are up.
Yes, I do have a question.
Please go ahead, Israel.
All right. So he has already, like, you've already answered some of it, but I just want to ask again. So I'm a mechanical engineering student, right? But I see the need for machine learning to have that technical skill. That's why I'm like focused, like I'm building that skill basically. So my question is, if, for example, sometime in the future, I decide that I want to apply for a machine learning data science role, do I have to have that degree, like in computer science, or my mechanical engineering, like, will it affect it? Do I still need a degree, basically, for them to take me serious? Because most of these guys in AI, all these, they are like usually masters and PhD roles and stuff like that.
Okay, so to answer the question, no, you don't need a computer science degree, which is where I think some companies get it wrong. As a student as a graduate of computer science, I feel like the brilliant computer science students sometimes have more relevant information than their lecturers. And if that's the case, because personally speaking, the computer science, I don't think computer science has reached the level that it should be at in Nigeria yet. It's still yet to get there. So even recently, not recently, actually, last year, I spoke to a graduate of mechanical engineering, and it was my topic for an ML intern role because in his free time, he had done impressive projects, not just, in fact, nothing related to finance. Most of them were oil and gas based, and they were impressive where he was describing them. So yeah, I don't think personally, I wouldn't look at whether or not somebody has a computer science degree if they're applying for an ML role.
Okay, Israel,
Thank
does
you.
that answer your question?
Yeah, it does. Thank you very
Okay.
much.
Hi, Dio, do you still have a question?
Yeah, I still have a question.
Please go ahead.
Um, and like me, right? I'm a CS major, right? I'm a CS major. The problem I have, right, in schools, in Nigerian universities, they don't teach us, like in I have a friend that is in abroad, right? The way they teach is come out different in terms of CS major. Like the things that are not practical, things that are not practical, that's what they don't teach us. Like that's what I say. But in terms of machine learning and all this, like AI, all this, do I really need a PhD or a master's to start like upgrading my level? Let's say I want to be in a I'm a junior machine learner. I want to go to a senior role. Do I really need a degree? Or basically is all the skill sets? So which one is kind of better in like foreign you going for foreign companies, like all these foreign companies, working for foreign companies? That's it.
Yeah, so that's a tricky question because you could go either way. You could have just a BSc because I don't have a master's or a PhD. You could have just a BSc and have so much experience. But at the same time, if you have a master's and you have the same number of experience that the BSc person has, then a company might just give the MSc or the PhD person, you know, chance over the BSc. So yeah, I mean, if you're thinking about getting an MSc in artificial intelligence or data science, then you should definitely go for it. I wouldn't tell as long as they know what they're doing there, because you don't want to waste your years only to find out that only to come out from the uni and find out that like nobody rates your degree. So you have to, if you're doing the school, you have to do it well. You have to go to a good university that counts for something when you come out. So yeah, definitely I'll recommend a master's. It's not very important that you get a master's. It's not do or die, right? But yeah, it's definitely the good ad.
Okay, thank you very much, sir. Okay, so please, to the audience, do we have any other question? Anything that has been bothering you? Okay, so I think I'm just gonna do a recap of the session because that's been very, very insightful. I personally have learned a lot, and I think we're saying from the aspect of research, and it really emphasized on research, research, research. And I think personally, that's something that made me understand the bridge between the academia and the industry because the industry still do research. So like there is this bridge that connects both fields together. Then we talked about EDA, we talked about data ingestion, we talked about future engineering and future selection. We looked at the model building and we also looked at deployment. Then we also answered questions. That's the assessment that was just joining. We also answered questions around where people are at their career front, the questions that are bothering them. Israel and Dio, do you still have questions to answer up?
Yeah.
Okay, Dio, please you have the floor.
Okay. I'm actually I'm a full stack, right? A full stack, also like doing some AI projects. So I'm trying to like stay into full stack and also trying to go into like AI learning. Is it the best? I'm mostly a tech stack of like JavaScript and little Python. So is it the best? Can I also like do the two in the sense that I finish a full stack development and go into AI? Is it a great advantage as a person in 100 level right now?
Okay, so if you're talking about AI engineering, then yeah, um, a transition from being a full stack to an AI engineer will be almost seamless because you'll be doing the same thing. The only thing is that you'll be building it on an LLM. So it's not going to be it's going to be a very smooth transition.
Okay. So I saw a question in the chat now, and the person says, I would love to dive into ML research. How do I go about it?
Sorry, come again.
Okay, so Confidence says, I would love to dive into ML research. How do I go about it?
What do you mean by ML research? Are you researching about the career or what exactly do you mean? Confidence?
Hi, Confidence. Do you like to unmute? Okay. So I don't know, Confidence. Do you like to unmute? Can you hear me? Okay. So okay. Hey, Dio, do you still have a question?
Yeah, I still have a question.
Okay, please let's have that. We're about to round up.
Okay. My own question is like to junior developers, right, or people who just start into tech. What is the best way to learn right now? Is it by using AI or start from the grid low? So what is the best way to learn for people generally who want to go into tech right now? Because I think AI is the one that is actually giving some people doubts on going to tech because some people thinks that AI is the main thing. So I'm kind of confused.
Yeah, I mean, as a dev, you can definitely use AI to learn because AI, even by seniors, is used as assistants. So it's not like those seniors don't know what they're doing. They know what they're doing. They just want to do it faster and they want to have time for other things. So yeah, as a junior dev, you can use AI if you're confused about the pathway to use, just the pathway or a roadmap. Just ask. You can actually just literally ask AI and it's give you a good pathway. It can suggest books for you to read. Books are very important. If I did not mention that before, books are actually quite important. I know a couple books that would help for AI engineering and for ML as well. But yeah, books are important. It can give you books to read, videos to watch, people to follow, Reddit or subreddits to follow as well. So yeah, AI can give you that roadmap, but I don't think it can give you the entire content that you need because you might not know the questions to ask in order for it to give you that content. So you need more of a structured learning pathway. And I'm not sure AI is the best for the job, but it can give you that initial guide. Definitely can give you that initial guide.
Okay, thank you very much. Okay, so Confidence is elaborating on our question. So the other question was just, I would love to dive into ML research. How do I go about it? So she said, like academic research that leads to implementation.
Mm, okay, I mean, it's just like I said before, you can use, you can start with research papers. When you get research papers, you actually know what you're doing, you know what you're working on, you understand the project scope. Why are you building projects? What are you building for? How long do you have? And then from there, it just kicks off. You do your data cleaning, your EDA, your feature engineering, and your training and testing. And then you can, for a for a for an individual based project, you can just deploy on popular platforms like Streamlit or Verso and just essentially demo what you built.
Okay, thank you very much for that. Okay, so the last question we're going to take for the day, then we'll round off, is you mentioned that to show that you know what you're doing in ML, you need to understand it from the basics. What pathways do you suggest to go about this?
Understanding it from the basics. Um, so I'm sure when you do like a course, they walk you through that course in bits and pieces and in phases. For example, let's say you've taken on the IBM course, the IBM data science course. They would start with pre-processing. So for pre-processing, from what I remember, there's really nothing technical there. But if you go into EDA, you'd see that's where you start seeing some technical stuff like the libraries. So, sorry, not the libraries, the different plots. So you need to understand now that phase is you're sort of operating as a data analyst. So you need to understand what plot or what graph or what visualization is best for what data type, right? So you go deeper. And where you even go deepest is in terms of feature engineering and ML and model training, where you have to understand the algorithms. So are you using a regression model? Are you using XGBoost? Are you using what's this called? Are you using random classifier? You know, so like you need to understand what these algorithms are. You need to understand the math behind these algorithms. So you can just start from the basic stuff like the different phases. So with each phase, comes its own set of hurdles, and you need to understand those hurdles. So it's not like you just dive into one random concept and start reading about the concept. You just need to understand the context in which that concept is used in, and then you understand the concept itself, and then you're good.
Okay. Thank you very, very much for your time, sir. Thank you to everyone who stayed with us to this time. And I really hope we have taken one or no, not even one. I hope we have taken 2, 3, 5 things that we are going to be implementing for end on. Thank you very much, Christopher, on behalf of the GDG OAU community. Like to say a very big thank you for heeding to our call. Like to say a big thank you to our audience for staying, for engaging, for asking questions. Thank you, everyone. So for those of us who requested for the recording, as long as you registered, you are going to get the recording for you to always go back to the sessions. Thank you, everyone, and have a nice week ahead and a lovely Sunday evening.
All right. Cool.
Thank you.
Thank you.